steady state thermal analysis conduction. Okay, here we can see that we have a slab here. One is made up of two materials, one is copper as well as the bakelite. Okay, so let us analyze this using an ANSYS workbench. Let us open the ANSYS workbench. First, I'll go for the steady state thermal. As I told, it is a thermal analysis where here the temperature does not be dependent upon the time. So we are doing the static thermal analysis here. Okay, steady state thermal analysis. I select here engineering data, edit. We have two options here. We can see in the figure that we have one is the copper as well as the bakelite. So we have a, already defined libraries. We can select from that. So now here go to the engineering data sources. We should select the thermal materials. Here we have a different materials here. So I'll go for thermal materials. With thermal materials, you have to select the two material. One is the bakelite as well as the copper. Now I'll select the bakelite from here. So bakelite add plus. Similarly, I'm selecting the copper here. Okay. Copper select plus. So the two we can see that we have a mark here. Bakelite is selected as well as the copper is selected. This completes the step number one because as already they are given the two materials. So from the defined libraries we can select this. Now go to the project. I'll go for modeling. General sorry. Before that I'll create a geometry. In geometry select a new design modeler geometry. Okay. Here same. I'll take the XY plane. Right click. Look at and the units I'll change it to millimeter. Okay, now first what I will do, you can see this figure here. First I will give the this cross section, that is 100 into 40 cross section. I will create this one and I will do the extrusion for the two different materials what we did for the last problem. First I create this 100 and 40 now. So I will select a sketching. Sketching, select rectangle. Now draw the rectangle here. So rectangle. Now go to the dimensions. Dimension general, select this and this. As we know that this length is 100 I told that this cross section should give 100 and this is 40 So now I'll give H1 as 100 and V2 as 40 So we can see this the rectangle is being created. Now what I will do here is I will do the extrusion. As the first element is the copper which I can extrude to 120 For bakelite I should extrude to 80 Now what I will do here is here. Now first I'll go for the extrusion, apply, add material is already is there, and here you have to give the depth of this one. The depth of this one is what we have seen that it is having the 120 So I'll give 120 Now give generate. Generate. Now see if you want to see this one, rotate this. So we can see that we have the created the first slab. Okay. So now I should create the another material which is the bakelite of 80 extrusion I should do. So I'll select this plane. From this plane I should select. Now select the plane. Here we have a faces. Select this and go to this one. Okay. So after this, here you have to create a plane. You have to create a plane and go to the sketching. Give generate and go for the sketching. Here the sketching same rectangle from this point you give the same. Okay, should give the same rectangle. Select from this correctly. Should select this one and give like this, and now give generate. Now similarly, I should give the extrusion for this. So I'll go for the extrude. Now here in extrude, I have to give a add frozen because since I'm doing the second material, change this add material to add frozen. Add frozen. Now what is the distance of the second element, that is a bakelite is of 80 give 80 and now give generate. Now what I'll do here is I'll rotate this and I'll check. So you can see that two materials is being created. Okay, so you can see the two materials is created. So this is part two parts. You can see the two parts is created, part one as well as the part two, solid one and solid two. This is solid one of the copper of 120 extrusion, and this is next one is the bakelite of 80 This completes the second step. Next step will go for the modeling. Next is modeling. Right click, edit. Modeling. The modeling. Here modeling, you can see that we have two materials is being created. Now go to geometry. In geometry, select the first solid. By default, it will be having the structural steel. We should convert it to copper as bakelite. The first element I given as the copper of 120 mm. So I'll take copper. Next material, I'll take the bakelite. Okay, so this completes the geometry. Now I'll go for mesh. Right click, generate mesh. Generate mesh. This complete the second step. Now I should apply the boundary conditions. Boundary conditions. This is the copper and this is the bakelite. Now I should go for the boundary conditions, steady state thermal here. So we can see here the first node in the figure. We can check here the first copper surface. This surface is temperature of 350 degrees Celsius and this is a temperature of 22 degrees Celsius. Now what I'll do here is, now this is the copper. Now I select steady state thermal analysis. Now I should apply the before that I should create insert temperature. Okay. So I should insert a temperature here. So what I'll do here is I select this phase. Select this phase. Now the temperature of this one is 350 degrees Celsius in this copper. Okay. So now what I'll do here is I'll give 350 degrees Celsius. 350 degrees Celsius. Now apply. Select the surface and give surface so that we can see temperature of 350 degrees Celsius is applied. Similarly, at node number 3, I should apply temperature of 22 degrees Celsius. Now again rotate. Here again select the face. Select the face. Before that, I create a temperature here, insert temperature. Now the temperature here, I am applying a temperature of the second phase. That is temperature is of 22 degrees Celsius. 22 degrees Celsius. Now give apply so that the temperature 1 is 350 degrees Celsius, temperature 2 is 22 degrees Celsius. If you want to check the boundary conditions using, you have done the two, one at this one and one at this one. Now the boundary conditions is completed. Now go for the solve commands. Solve. Now I should determine the nodal temperature. Go to solution, insert thermal temperature. Now evaluate all results. Evaluate all results. Now we can see the temperature. Here you can see that we have the maximum temperature of 350, red color, maximum temperature of 350 degrees Celsius and minimum is 22 degrees Celsius. Now I want to check at each this one. I should go for the probe. So now what I can do here is solution, insert probe temperature. Now when we go for the probe, now solution, evaluate all results. Select the probe here. Now here if you want to see the probe, now you can check wherever you want the temperature, you can select that. See here, this is the different temperatures, okay, at these points, and red is the maximum 350 maximum and 22 is the minimum temperature distribution. Okay, so this completes the problem. Now I want to see an Excel sheet. Now solution, worksheet, result summary. So you can see that the minimum temperature is 22, maximum is 350 degree Celsius.